Hey guys, this is iTower. In this video, we're going to build a to-do list app from scratch using JavaScript, HTML, and CSS. This project will teach you how to handle tasks like creating, editing, and deleting to-dos. We'll dive into some useful features, such as filtering tasks based on their status, sorting them in different ways, and even exporting as a JSON file. By the end of this video, you'll not only have a fully working to-do app, but you'll also gain valuable experience in managing user input, working with the DOM, and organizing data in your application. These are the kind of skills you use in real-world projects, so it's a perfect addition to your portfolio. If you're looking to enhance your JavaScript skills or want to build something practical that showcases your abilities, this project will help you strengthen your front-end development expertise. Let's dive into the code and get started. Our project is organized into three main files: the HTML file, which defines the structure of the app, the CSS file for some additional styles, and the JS file where the JavaScript functionality comes together. Let's start with the HTML file, particularly the head section. First, we specify the character encoding to make sure text displays properly across all devices. Then, we set up the viewport for responsive design, ensuring the app adjusts its layout for mobile and desktop screens. We also set a title for the app that shows up in the browser tab. To make the design process easier, we include the Tailwind CSS framework. Tailwind is a utility-first CSS framework, meaning we can apply styles directly in the HTML using utility classes. This allows us to quickly build and style the app without having to write a lot of custom CSS. Additionally, we link to Font Awesome, which gives us access to a wide variety of icons for a more polished and user-friendly interface. Lastly, we connect our own custom.css file, where we'll define some unique styles for our app. Let's dive into the body section of the HTML and break down the structure. First, we wrap everything in a div that helps center the entire page and apply some padding around it. The layout is flex-based, which means elements inside will be arranged in a flexible and responsive way. We ensure that everything is placed neatly in the middle by adjusting the items and justifying them to the center. Inside this container, we have a main div that holds all the content. This div is styled to be visually distinct with a white background, rounded corners, and a subtle shadow to make the content stand out. It has a specific maximum width to keep things contained. Now if we refresh, we can actually see the centered card. It's sitting nicely in the middle, has rounded corners, a soft shadow, and it already feels like the skeleton of our app. Next, we move to the top part of the page, where we have the header section. The header itself is wrapped in a div with a gradient background that goes from violet to a lighter violet shade. Inside the header, we have a title, which stands out with a bold font. Right under the title, there's a short description to provide some context to the user. This text is styled in a lighter shade of violet to contrast with the header background. To the right of the header, we have an icon inside a circular container. This container has a semi-transparent background with a subtle blur effect. Inside the circle, we place an icon representing the task list. There's also a badge on top of the icon that displays the number of tasks initially set to 0. This badge is animated to pulse, giving it a dynamic feel. Let's take a look at it now. The gradient header is in place, the title stands out, the subtitle is easy to read, and on the right we've got the task icon with a little badge bouncing. It already feels more alive. Right below the header we find the task input form. This form allows users to add new tasks. We start by providing a large input field where users can type their task. This field is designed to expand and fill the available space with a soft shadow effect and a focus ring that gives feedback when the user interacts with it. There's a button next to it, allowing users to add the task. The button is styled to blend seamlessly with the background and provides a hover effect for interaction. The form also includes two drop-downs for selecting the task category and priority. These drop-downs allow users to filter their tasks based on different aspects. The categories range from general tasks to work, personal, shopping, and health-related tasks. For priority, users can choose from low, medium, or high, with medium selected by default. Both drop-downs are designed to look consistent with the rest of the layout, featuring a subtle background and border effect. Now let's see what this looks like. We've got the input field, the add button, and both drop-downs sitting right there. They line up nicely and the styling matches the rest of the app. It's starting to feel like a real task manager now. Below the form, we have the filters section. This section contains buttons for filtering tasks by their status, whether they're active or completed. These buttons are styled to change their appearance when hovered over, giving users immediate feedback. There's also a drop-down for sorting the tasks, allowing users to sort by various criteria such as newest or oldest first, priority, or category. If we reload, the filter buttons are there and the hover effects are working. The sorting drop-down is in place as well. Everything is interactive already, which is nice. Next, we get to the task list. This area will dynamically display all the tasks as they're added. If there are no tasks yet, we show a message encouraging the user to add their first task. The task list is scrollable, so users can keep adding tasks without the page becoming overcrowded. Checking the page right now, we just see the placeholder message telling us to add the first task. Looks clean, and we know it'll update once we add tasks later. At the bottom, there's a footer that displays statistics about the tasks. It shows how many tasks are left to complete and provides buttons for clearing completed tasks or exporting the list. These buttons are interactive and change their color when hovered over. Now, at the bottom we can see the footer with the counters and the action buttons. They're styled consistently and the hover feedback works fine. Throughout the HTML structure, the layout is designed with flexibility in mind, using a combination of flexbox for alignment and spacing. The overall goal is to ensure that everything looks neat and easy to navigate. Now let's quickly go through the full HTML structure so you can see how everything is organized. If the overall structure feels unclear to you right now, don't worry, you can check it again on GitHub using the link in the description or simply rewatch parts of this video, and it will make much more sense. The structure itself is quite simple, so you shouldn't have any trouble getting used to it. Now, let's go over the CSS styling for the page. First, we import a font from Google Fonts. We're using the Poppins font, which comes with multiple weights, so we can make the text look either light, regular, or bold, depending on where we need it. For the body, we set the Poppins font as the default and apply a soft gradient background. It goes from a light gray to a subtle blue, giving the whole page a fresh and modern look. We also make sure the body stretches to the full height of the screen, so that gradient always fills the entire viewport. Then, we customize the scroll bar to make it cleaner. By default, scroll bars can look bulky, so we slim it down to 8 pixels wide, give the track a light gray background with rounded corners, and style the thumb with a softer gray. When we hover over it, the thumb darkens slightly to show interactivity. To add some motion, we create a bounce animation. This makes elements move up just a bit and return to their place, giving them a quick, lively effect whenever the animation is triggered. Now let's switch to the browser and see everything working together. The gradient background is visible, the font is applied throughout, tasks can be checked off and marked with a line through, and the scroll bar looks clean. With these styles in place, the whole page feels more interactive and modern. Now that we've finished setting up the styles with CSS, let's move on to JavaScript. We start by selecting all the elements we need from the DOM. These include things like the input field where we'll type the new task, the button to add the task, the list where tasks will be displayed, and a few others for filtering, sorting, and exporting tasks. Next, let's initialize the state of our application. In JavaScript, state refers to the data that determines how the app behaves and appears at any given time. For our task manager, the state includes the list of tasks, the active filters, and the sorting settings. To begin with, we store the tasks in an array, which is a data structure that allows us to organize and manipulate the list of tasks easily. We then retrieve this task list from the browser's local storage. Local storage is a feature that allows us to store data in the browser, so even when the user refreshes the page or closes the browser, the data is preserved. By checking local storage, we ensure that any tasks the user has added previously remain intact. If there's no data saved in local storage, we initialize the tasks array as an empty one. Additionally, we set default filters and sorting options to define how the tasks are displayed. The default filter is set to show all tasks, meaning no tasks are hidden based on their completion status, and the default sorting is by newest, which means tasks will be displayed in the order they were created. This setup gives the user a starting point with a pre-configured, simple view of the app. Now, let's handle adding new tasks. This part of the code is about allowing the user to input a task and then add it to the task list. To do this, we add event listeners to two elements, the Add Task button and the input field where the user types the task. The event listener attached to the button listens for a click event. So when the user clicks the button, it triggers the Add Task function. In addition to this, we want to give the user the option to add the task by pressing the Enter key as well. To do this, we add a second event listener on the input field. This one listens for the key press event, and inside the function we check if the key pressed is Enter. If it is, the Add Task function is triggered as well. Now let's take a look at how the Add Task function works. This function is responsible for taking the input from the user and adding it to the task list. First, we retrieve the text that the user entered into the input field. The trim method is used to remove any extra spaces from the beginning or end of the input to ensure we don't add a task with just spaces. If the input is not empty, the function proceeds with creating a new task. We generate a unique ID for the task by using dateNow, which returns the current timestamp in milliseconds. This gives us a unique identifier for each task that is added. Along with the text, the function also stores the task's completion status, the creation time, the task's category from a drop-down menu, and its priority level. After the task object is created, we add it to the beginning of the tasks array using unshift. This ensures the new task appears at the top of the list. We then call three functions: save tasks, render tasks, and update stats. We will explore each of these functions in more detail later, but essentially, they do what their names suggest. Save tasks ensures the task data is saved, so that it persists across page reloads. Render tasks updates the UI with the new task, and update stats refreshes any task-related statistics, such as the number of tasks or completed tasks. Once all of this is done, the input field is cleared by setting value to empty string, and the focus is returned to the input field with focus method, so the user can immediately start typing the next task if desired. Let's dive into the render task function, which is responsible for displaying all the tasks on the page. The first thing the function does is filter and sort the tasks based on the user's selected preferences, such as which filter to apply and how to sort them by creation date or priority. This filtering and sorting is handled by the filter and sort tasks function. The filter and sort tasks function is responsible for filtering and sorting the tasks. This function is essential because it determines how tasks are displayed to the user based on their selected filter and sorting preferences. First, the function makes a copy of the tasks array to avoid directly modifying the original array. This ensures that the tasks remain intact for other operations. The copied array is stored in the filtered variable. The function then checks the value of the current filter variable, which holds the user's selected filter option. If the filter is set to active, the function filters the tasks to only include those that are not completed. This is done by checking the completed property of each task. If the task is marked as completed, it will be excluded from the list. Alternatively, if the filter is set to completed, the function filters the tasks to include only those that are marked as completed. Similarly, the completed property is used to determine whether the task should be included in the filtered list. After the tasks have been filtered, the next step is to sort them, and that's where the sort tasks function comes in. What this function does is take that filtered list and organize it based on whatever sorting option the user picked. So, for example, if the user chose to see the newest tasks first, it'll sort them by creation date, starting from the latest one. If they picked oldest, it'll do the opposite. Show the oldest tasks first. If they prefer to sort by priority, the function will look at whether the task is high, medium, or low priority and order them accordingly, putting the most important ones on top. There's also an option to sort by category, where tasks are arranged alphabetically based on their category name. In short, this function decides the final order in which the tasks will be shown to the user. It makes it easier for people to quickly find what they're looking for, whether that's the most urgent tasks, the newest ones, or just grouping things by category. Once the tasks have been filtered and sorted, the function proceeds to create HTML elements for each task. However, before adding any tasks to the page, the function first checks if there are any filtered tasks. If there are no tasks to display, it creates a special message indicating that no tasks are available. This message is displayed when the user's filter criteria result in no matching tasks. The empty state message is generated by a helper function called createEmptyStateElement. This function is used when there are no tasks to display after filtering. It creates a list item element to show a message informing the user that the list is empty. The function takes the current filter as an argument and, based on its value, sets a corresponding message. For example, no active tasks if the active filter is selected, or no completed tasks if the completed filter is selected. If no specific filter is applied, it simply shows no tasks yet. Along with the text, the function also includes an icon to visually indicate an empty state. This list item is then returned, so it can be inserted into the page, helping keep the interface informative and user-friendly even when no tasks are available. If there are tasks to display, the function then loops through the filtered tasks, creating an HTML element for each task using the createTaskElement function. This function will generate the necessary HTML structure for each task, such as the task's text, completion status, and options for editing or deleting. Each generated task element is appended to a document fragment, which is a lightweight container used to hold the tasks temporarily before they are added to the actual DOM. This approach helps improve performance, as the fragment is only added to the DOM once, after all tasks have been processed. As for the createTaskElement function, we won't go deep into it. You can quickly glance at what it does on the screen, and I'll also leave a link to the full code in the video description for those who want to explore it in more detail. But before we move on, let's take a quick look at a few small helper functions that are used behind the scenes to make things look better. The getCategoryClass function is all about styling. It takes the category of a task, like work, personal, or shopping, and returns a CSS class that gives it a matching background and text color. So tasks from different categories are visually distinct when displayed. Then there's the getCategoryIcon function. Just like with the colors, this one returns the right icon based on the task's category. For example, if the task is related to health, it shows a little heartbeat icon. If it's a shopping task, you get a shopping cart icon. Next, we've got the getPriorityClass function. This works similarly to the category class 1, but focuses on priority. A high priority task might have a red background, medium might be yellow, and low is usually gray. It's a quick visual way to see what needs attention. Then, the getPriorityIcon function is similar to the categoryIcon 1. It gives each priority level its own icon. High priority might show an upward arrow, medium gets an equal sign, and low priority gets a downward arrow. It just adds a little more visual clarity to the tasks. And the last one, the formatDate function. This one makes the task's date look friendlier. Instead of showing a full date and time that might confuse users, it makes it more natural to read. For example, if the task was created today, it'll show today at 2:23 p.m. If it was created yesterday, it says yesterday at 2:23 p.m. If it's been a few days, it'll just say 3 days ago, or whatever the number of days is. And if the task is older than a week, it will just show the date, like May 10 or May 10, 2024, depending on the year. Finally, the renderTasks function clears the current contents of the task list container and appends the fragment containing all the task elements. This ensures that the page always displays the most up-to-date list of tasks. After updating the task list, the function calls another helper function, attachTaskEventListeners, to attach event listeners to each task element. These event listeners allow the user to interact with the tasks, such as marking them as completed, deleting them, or editing their details. In summary, the renderTasks function handles displaying the tasks based on user preferences, ensuring that the tasks are properly sorted and filtered, and dynamically updating the page with the correct content. If no tasks match the filter, it shows an empty state message, and if tasks are available, it generates HTML for each one and updates the page. Let's break down the attachTaskEventListeners function and the two key functions it utilizes, editTask and toggleTask. The attached task event listeners function basically makes the task buttons and checkboxes work. It goes through all the checkboxes and listens for when you check or uncheck them. When that happens, it calls toggle task to mark the task as done or not. It also adds a click listener to every delete button, so when you click it, delete task runs and removes the task. And for the edit buttons, it listens for clicks too. When you click one, edit task is called, so you can change the task text. Next, the toggle task function. This function is triggered when a user clicks a checkbox associated with a task. The purpose of this function is to toggle the completion state of a task. Inside toggle task, the ID of the task associated with the checkbox is retrieved. Then, the function checks whether the checkbox is checked, indicating that the task is completed. If the checkbox is checked, the task's completed property is set to true, marking the task as done. If the checkbox is unchecked, the completed property is set to false, indicating that the task is still active. After updating the task's completion status, the saveTasks function is called to store the updated list of tasks in local storage, ensuring that the task state persists even after a page reload. Finally, the task list is re-rendered, and the stats are updated to reflect the changes in the number of completed tasks. Now let's look at the edit task function. This function is triggered when a user clicks the edit button next to a task. The goal of edit task is to allow the user to modify an existing task. When invoked, the function first identifies which task is being edited by looking at the ID of the task associated with the clicked edit button. It then loads the current details of the task into the input fields, allowing the user to make changes. After the user has made their edits and submitted the changes, the edit task function updates the task's properties with the new data. This can include updating the task's text, category, priority, etc. Once the task has been updated, the saveTasks function is called to store the modified task list in local storage, and the task list is re-rendered to reflect the changes. These two functions, toggle task and edit task, are critical for allowing users to interact with their tasks, either by marking them as complete or by editing their details. The attached task event listeners function ensures that the right event listeners are in place to trigger these functions when the user interacts with a task. Let's now take a closer look at the sorting function, which is responsible for organizing the tasks based on the selected sorting method. This function begins by evaluating the current sort variable, which holds the selected sorting option, and applies the appropriate sorting mechanism based on that value. If the option is set to newest, the tasks are sorted by their creation date in descending order, meaning the most recent tasks will appear first. This is achieved by comparing the created at property of each task using the sort method. In contrast, if the option is set to oldest, the tasks are sorted in ascending order, with the oldest tasks appearing first. The same comparison mechanism is used, but the subtraction of dates is reversed. If the sorting option is priority, the tasks are sorted by their priority levels. A numeric value is assigned to each priority, high, medium, low, using the priority order object, and tasks are sorted based on these values, ensuring that high priority tasks are listed first. If no sorting option is selected, the function returns the tasks in their original order without applying any sorting. Next, we look at the update stats function, which serves to update and display useful information about the task. It updates two key pieces of information: the total number of tasks and the number of tasks that are still incomplete. It does this by setting the text content of the task count element to reflect the total number of tasks, which is simply the length of the tasks array. Then, it updates the remaining tasks element by filtering out the tasks that are marked as completed and counting how many tasks are still pending. This helps users quickly track their progress and see how many tasks they still need to finish. Now, let's dive into the delete functionality. When a user clicks the delete button next to a task, the delete task function is triggered. This function first identifies a task that was clicked by retrieving its ID, which is stored in the data ID attribute of the task's HTML element. It then filters the tasks array to remove the task with that specific ID, effectively deleting it from the list. After the task is removed, the function updates the task list by saving the new array of tasks, re-rendering the UI to reflect the changes, and updating the task statistics to keep everything in sync. This ensures that the user always sees an up-to-date view of their tasks, with the deleted task no longer appearing on the page. After initializing the render tasks function, we also call the updateStats function. This function updates the task statistics, such as how many tasks are active, completed, or the overall task count. It ensures the user is kept informed about their task status after any changes, whether it's adding, removing, or completing tasks. Let's now take a closer look at the event handlers and the functions they trigger. The first one we'll discuss is the clearCompleted btn. This button listens for a click event, and when it's clicked, it triggers the clearCompleted function. This function removes all completed tasks from the list, helping the user keep their task list organized. Inside the clearCompleted function, we also call saveTasks to update the stored task list, and then renderTasks is called to re-render the task list. Finally, updateStats is triggered to refresh the task statistics after clearing the completed task. Moving on to the exportTasks btn, it listens for a click event as well. When the user clicks this button, it runs the exportTasks function. This function is responsible for exporting the task list, allowing the user to save or share their tasks in an external format, such as a JSON file or CSV. The format of the export can vary based on the specific implementation, but the main goal is to give the user the ability to take the current task list and save it outside the app. Inside the exportTasks function, we first gather all the current tasks and prepare them for export. If the task list is being exported as a JSON file, for example, it will be converted into a JSON string using JSON stringify. Once the tasks are in the right format, the function creates a downloadable file that the user can save to their computer. For JSON exports, this might involve creating a blob, a binary large object, from the JSON string, generating a URL for it, and then triggering the download by creating a temporary link element and simulating a click on it. This allows the user to download their tasks without needing to copy them manually. After the tasks are exported, the saveTasks function is typically called. This is crucial because if any changes were made to the tasks before exporting, like adding, removing, or updating tasks, calling saveTasks ensures that these changes are saved to local storage or the database, depending on where the tasks are stored. This ensures the user's data stays up to date even after exporting the task list. To sum up, the exportTasks function takes care of exporting the task list, letting the user save it in their desired format, and after that, saveTasks ensures any changes are properly persisted. Next, we have the sort select dropdown, which has a change event listener attached to it. When the user selects a new sorting option, it triggers the sort change, updates the current sort variable with the selected value, and calls renderTasks to re-render the tasks based on the new sorting criteria. This could be by creation date, priority, or any other criterion. After the sorting process, updateStats is called to update the task statistics accordingly. Finally, for the filter buttons, we'll loop through each button and add a click event listener. When a filter button is clicked, the script first removes the active styles from all buttons, and then adds the active styles to the click button. Afterward, it updates the current filter to the filter associated with the click button, and then renderTasks is called to re-render the task list according to the new filter. This allows users to filter tasks by criteria like all, active, or completed. After applying a new filter, updateStats is triggered again to reflect the updated task statistics based on the current filter. In summary, each of these event handlers plays an essential role in managing the task list by triggering functions that update the view, export the data, and keep the task statistics up to date. And that's all for today. We've covered everything in a conversational style so you could see how the app works in action. Throughout this walkthrough, you've learned a lot, especially about export and how to work more deeply with JavaScript and the DOM. You've also had the chance to practice creating your own logic and focusing on modularity, which is key for building scalable apps. If you found this video helpful, don't forget to hit the like button and subscribe for more content. Also, Feel free to leave any comments or questions below. I'd love to hear your thoughts and help with anything you need. Thanks for watching, and I'll see you in the next one.